Survey data obtained from Lidar scanning can be used to create point cloud objects. Lidar stands for light detection and ranging. Sensors are used for scanning the Earth's surface, and resulting data is stored in files called point clouds. A point cloud is a collection of 3D data that can represent ground, vegetation, building models, or other natural and man-made objects. Point cloud data is commonly stored in a variety of different formats. In this example, we'll create a Civil 3D point cloud using point cloud data from an Esri type file. Of course, as with everything in Civil 3D, you should be aware of the styles and settings applicable to the point cloud object. If you go to the Settings tab, you'll notice the point cloud category where you can define different point cloud styles, as well as define command and feature settings for the different point cloud options. If you look at one of these styles, you'll notice that you can tell Civil 3D how you want the points to display. If the objects are classified within the point cloud file, it'll actually display them in different colors, and you can put them on different layers as well. And of course, what part of the point cloud object do you want to display in the plan and the model view. To create a new point cloud, simply navigate to the point clouds collection in the Prospector tab, right-click on it, and select Create Point Cloud. We'll leave the default name, and we'll leave the default style applied. In this case, it says Lidar Point Classification, and we'll go ahead and click Next. Note the options to select different types of point cloud files. There are many kinds of files that Civil 3D supports. For this video, we're going to use the Esri ASC file format. We'll go ahead and click the plus sign to navigate to the Point Cloud Files folder. Again, this is under Civil 3D Projects, loading AutoCAD Civil 3D, Infinite Skills, Point Cloud Files. You can select more than one point cloud file if you want to. This will combine all the point cloud files you select into one Civil 3D point cloud file, which will eventually get created. We'll select just the first two and go ahead and click Open. Notice the coordinate system defined. Notice the option to also select an existing point cloud database. Again, this is a Civil 3D point cloud database, which has an extension of .isd. We'll go ahead and click Next. It summarizes everything we're about to do, and we'll go ahead and click Finish. Civil 3D warns you that a new database is being processed in the background, and you can continue working while this is being done. There's a notification in the bottom right side of the tray that will tell us when this point cloud file is created. Click Close. As you can see, you will now wait for the point cloud file to be generated by Civil 3D. When Civil 3D has completed the point cloud, you'll get the option to click here to zoom, which tells you it's also done. It doesn't look like much has been generated here, but if I hold the Shift key down and then middle button pan, you'll notice that we actually have a true point cloud file with 3D elevations and everything. At this stage in the game, you can simply view the point cloud. That's about it. Let's say we want to actually display some of the different elevation bandings within our point cloud files. Notice the point clouds collection contains the point cloud. We'll right-click on it and navigate to the point cloud properties option. First, let's go ahead and look at the Elevation Ranges tab, and we can change our ranges to whatever range we want to. Let's say I want to display 3. I'll go ahead and click on Update Range Details, and then what I can do is simply tell Civil 3D what ranges I want to display. So let's say I want to do 0 to 50 here, and we'll go from 50 to 70, and then we'll go from 70 to the maximum elevation. I'll go ahead and click OK, and I should expect it to update with the elevation banding, but as you can see, it's not. The reason it's not updating is because that style was a Lidar classification style. It was meant to display the classifications defined in the point clouds that we used to bring in. Let's go back to the point cloud properties, and what we can do is simply change it to the style which already exists in this file. For elevation ranges, this style tells Civil 3D to automatically use the elevation ranges defined in this style. So as you can see, we now actually are displaying the different elevation bandings that we want to see within the point cloud file. Now what you can also do is you can actually select the point cloud. When you do so, you get a contextual ribbon, and this allows you to change the point density. You can also change the real-time density here. You can also change the properties and so on. You can also click on the Add Points option here, and what this actually does is this allows you to add additional point cloud files if you want to. So let me go ahead and click the plus sign here, and we'll just go ahead and maybe add 1 or 2 more in here. We'll go ahead and click Open, and click OK, and of course you get that same exact notification that tells you it's going to load those in the background. And of course you still can actually go in here and work in your Civil 3D environment, doing whatever you need to do until the point cloud object is generated. You can of course click here to zoom and change any properties and so on. Lastly, let's actually show you what's going on in the background with the files that are being generated. So if I go back to my folder here, let's go ahead and go back into my drawings folder. And what you'll notice is that Civil 3D creates some additional files as I mentioned before. It creates a .iati file, a .isd file, and a .prmd file, which helps Civil 3D redisplay the point cloud. These files are now the point cloud files that are used to generate the point cloud data. This concludes this video discussing working with point clouds. Civil 3D provides a way for you to use point clouds as a Civil 3D surface that you can then use for design or as an existing ground. Notice how I already have a point cloud in my drawing. Let's select it, go to Point Cloud Properties, and let's set it to a no display style so that it will disappear from our drawing and our view is less congested. Right click on the EG point cloud, let's click on Add Points to Surface, and let's go ahead and call our surface EG. We'll give it a style here. Click Next. Notice the options to specify a region. You can do the point cloud extents, a window polygon, or an existing object. Let's go ahead and leave it at point cloud extents and click Next. And then we'll click Finish here, and our surface will get generated. This is a really cool feature, but one of the problems, of course, as you can imagine, with point clouds is the density at which the surface gets generated. Let's go ahead and change our surface style to one that shows the tin. And you'll notice that the triangles are very dense because of all the points in this surface. What you can do in this case is you can simplify your surface. Let's go ahead and expand the EG surface. We'll right click on Edits and go to Simplify Surface. You can do an edge contraction, but in this case, we want to actually do a point removal. We'll click on Point Removal, click Next. You can use the existing surface, or of course, if you want to do a specific region, in this case, we want to do the whole surface. Click Next, and then you can define the percentage. Now, of course, be aware of the problem that can occur here. If you take out too much of the surface, you will not have an accurate surface. So probably start with low percentages. And remember, these are surface edits. If you make a mistake, it's not a big deal. You can simply right-click on the edits collection and remove the specific Simplify Surface edit that you did. We'll just leave it at 25% here, and we'll click Finish, and our surface will get simplified. Our surface is less congested. Of course, you can re-simplify the surface if necessary, but that's one way that you can use point clouds as a Civil 3D surface. This concludes this video discussing creating a Civil 3D surface from point clouds.